So hello everyone, this is Shivani Singh and today I am gonna teach you chemical reactions and equations. This is the chapter 1 from class 10. So let's get started without any delay. So what do you mean by chemical reactions? Chemical reactions are the chemical changes in which the rearrangement of the molecules take place to get a product. Like take an example of photosynthesis. What happens? A leaf produces oxygen. So what is the process behind it? Like there must be something going on so that the oxygen is evolving from it. So there is a chemical reaction surely behind it. Take digestion. Thousands of reaction takes place when a digestion occurs. When the complex substances gets converted into simpler one. So a chemical reaction is taking place over here. Also breathing, how every tissue is getting oxygen from it, and we are releasing CO2. So some chemical reactions must be taking place, right? So and take an example of combustion. Energetic molecule along with the atmospheric oxygen releases energy in the form of fire. So there must be a process behind it. So every chemical change is behind every chemical change there is a chemical reaction. What do you see here? A rocket. So this rocket, what it goes upward, but how it goes upward? Here is a combustion chamber, and because of the combustion chamber, what is happening over here? There is fuel plus oxidizer, and this fuel and oxidizer combine to give the energy in the form of heat. There is a small slit over here, and through this the energy goes comes out, and this has some certain velocity, and this certain velocity tends to have a propellant character. So this is how the rocket goes up. This is a very simple science behind it. So here a chemical reaction is taking place. Okay. A chemical change happens when one chemical substance is transformed into one or more different substances, such as when iron becomes rust. You must have seen iron getting oxidized, iron having brown substance over it. So what do you get? What conclusion do you derive from it? Like it got rust. So what rust means is that when iron plus H2, the atmospheric moisture, and O2 reacts to form ferric oxide. So this is the brown substance which you see. Okay. So this is how the iron get rust. Chemical changes occur through the process of chemical reactions. Simple. And the resulting substance have different property because their atom and molecules are arranged differently. You can see here that the atoms and the molecules are arranged differently here, but a chemical reaction occurred, and because of this the ferric oxide got produced. So this is the product and this is the reactant. Reactant comprises of the atoms and molecules that combine together to change into a product. Okay. And what do you mean by this plus plus sign? This plus means that different atoms are combined together. Okay. That got add. and this arrow signifies the chemical reaction took place. Okay. An illustration for chemical reaction: burning of a magnesium ribbon here. Okay, you take a magnesium ribbon over here, you burn it through a burner. Then what happens? When magnesium burns, so there must be oxygen, atmospheric oxygen. So it got react with the atmospheric oxygen. Then what happened? Magnesium oxide got produced. So this magnesium oxide has different properties than the previous magnesium that was there. So this is the ribbon. Okay, it got reacted with the atmospheric oxygen because it was burned. So the magnesium oxide got formed in the and this was collected in the watch glass, and this is in a powder form. So do you see that the state got that the state got changed and also the property got changed, right? So this is how we can say that a chemical reaction has taken place when the reactant and the product have different properties. An illustration for chemical reaction: action of dilute sulfuric acid on zinc. Okay, so this is zinc. Zinc is denoted as Zn. Then sulfuric acid. It gives what? ZnSO4 plus H2. This H2 gets emitted because it is in a gaseous form. So here the state changed. Also, when you will touch this conical flask, no, there will be temperature change. It will be hot. And hot is also known as exothermic reaction. When a reaction releases energy, it is known as exothermic reaction. Or when a reaction is cold, it is known as endothermic reaction. So these are the properties, and these are the properties that signifies a chemical reaction. So this is an endothermic reaction when the conical flask is cold. Okay, but here it is hot, so this is known as exothermic reaction. So what happened here? The H2 gas got emitted. So how we can conclude this, that an H2 gas got emitted? You take a matchstick, burn matchstick over here. You will get to notice that here is a popping sound. A popping sound signifies here that here is the emission of H2 gas. Okay. Chemical reaction. So when a chemical reaction takes place, there is our change in state. You got to see that when zinc was reacted with sulfuric acid, ZnSO4 was produced and H2 gas got emitted. Okay. So here is change in state, change in color. Change in color you get to see when iron reacts with copper sulfate, and it is it is this. It gets converted into this and copper. So you will notice here that this copper sulfate has a significant blue color. Okay, and here it is converted into a green color. So here is change in color. This also signifies that a chemical reaction has took place. Chemical reaction has took place because there is a chemical change. Evolution of gas, H2 gets emitted. Change in temperature. Here is the example that it is an exothermic reaction because when you touch the conical flask, it was hot. So these are the characteristic property of a chemical change that has occurred. So you need to remember the 4 points: change in state, change in color, evolution of gas, and change in temperature. Okay. Chemical equations. The simplest way to represent a chemical reaction is in the form of an equation. I was writing a lot of chemical reactions here, right? So these reaction is can be represented in a simplest way. This is in the form of an equation. This equation comprises of the elements that got reacted, a plus sign, and this arrow, this signifies the change. Okay, and the product was formed. Right? Yeah. You can see here this. This is the chemical reaction when magnesium ribbon was burned and magnesium oxide was formed. So any chemical reaction, any chemical change that you see, it can be represented in a form of equation denoting it a plus and an arrow sign. Okay, so this is the proper way to explain any chemical reaction. Chemical reaction representation. Chemical equation representation. The substances that undergo chemical change in the reaction are called reactants, like magnesium and oxygen in the reaction of magnesium and oxygen. You know, when this magnesium was reacted with O2 to form what? Magnesium oxide. This is what? This is reactant. Okay? Because these two elements got reacted to form a product, that is MgO. This is magnesium oxide. Magnesium oxide. And this is what? Your product. Okay. The new substance formed. The magnesium oxide is the new substance formed during the reaction is called the product, that is magnesium oxide. Okay. In the reaction of magnesium and oxygen. So this is reactant and this is the product which you got when Mg and O2 reacted with each other. Some of the example of chemical reaction representation is that when carbon and oxygen reacts with each other, it forms carbon dioxide. This is also a combustion. This is also a combustion reaction. Okay. Also, when H2 gas and O2 gas reacts, it forms water. So this is how a chemical change, a chemical reaction is represented in the form of an equation to get a proper analysis of what chemical change occurred. Okay. Balanced chemical equation. What I did here, like in previous slides, I did that 2 Mg plus O2 gives 2 MgO. So you will get to notice that this is a balanced equation. You will understand it in the next slides. Okay. Balanced chemical equation. A chemical equation represents a chemical reaction. This is what we learned learned so far. Okay, which we have learned so far. Unequal number of atoms of any element on the LHS or RHS of a chemical reaction implies the mass of that element is not same on both the side of the equation. When I wrote this Mg plus O2 gives MgO, you can see here that there were the two atoms of oxygen reacting. Okay, but here in product only one oxygen got attached to the Mg. So there is some problem in it. Like this is not following the conservation of mass. Okay. Conservation of mass. What conservation of mass signifies that mass can neither be created nor be destroyed. Okay. So the number of atoms in each element present in the reactant shall be equal in the product. Okay, the number of the atom in each element in the reaction should be equal to the number of element present in the product. This is the universal truth and this can't be changed. Such a chemical is called skeletal chemical equation. Okay, example this. Got it? Let us take more examples over here. Dilute sulfuric acid is added to zinc. This is the word equation of it, like zinc, sulfuric acid in its dilute form, zinc sulfate, hydrogen gas, zinc sulfate and hydrogen gas for the product of it. Okay, these are the product and these are the reactant. Right. Chemical equation of it is zinc plus sulfuric acid in its dilute formed ZnSO4 zinc sulfate plus H2 gas which got emitted. So this is the proper representation of the chemical reaction. Example number 1. So how to balance a chemical equation? Every chemical equation follows conservation of mass. You need to balance the equation in left hand side and right hand side. So let us calculate the number of atoms of all the elements on both the sides. So let us take zinc plus sulfuric acid gives ZnSO4 plus H2. Okay. So what do you see here? Break it. This is left hand side. This is right hand side. This is not following. Consider this equation that this is not following conservation of mass. You need to check that if this is following the conservation of mass universal truth or not. Okay, this is the thing. So zinc, count the number of atoms in left hand side of zinc. Left hand side. Okay, so there is only one atom of zinc. Here there is only also one atom of zinc. So these both are balanced. We need not to balance it. Then what are the number of hydrogen present? 2. Here also 2. Then what? 2. This is same in right hand side as well as in the left hand side. Sulfur, count the sulfur. This is sulfur. Okay. This is sulfur. I think something wrong is happening. This is sulfur. Also this is sulfur. Then what? One atom and one atom in both the side. So this is balanced. Oxygen 4 and 4. Here you can see that 4 and 4. So this equation legit follow the conservation of mass. So this is a properly balanced chemical equation. Let us take an example number 2, in which the Fe, iron, combines with water to form Fe3O4 plus H2. So iron plus H2O gives what? Fe3O4 plus H2. Right. This is the equation. You need not to alter the equation. Okay. Whatever equation is written, you not need to alter any equation, any product or any reactant. You just need to check whether the number of atoms of each element is equal or not. So number of atoms in the reactants, there are 3 elements over here, Fe, H, You need to make a table. Okay, here is Fe. LHS में कितने हैं? 1. And number of atom in product, 3. Here is 3. Here is 1. So you need to do something over here because this is not following the conservation of mass. Then here in H, here 2 atoms of hydrogen, here 2 atoms of hydrogen. So we need not to change it, but we will see in future if we'll have to change it or not. And there is 2 and there is 4. Okay, so no, H2O, right? So in left hand side the number of O is 1. Okay, this is here, it is wrongly this is wrong here, over here. So number of oxygen is 1. Number of atoms in the product oxygen कितने हैं? 4. Okay, so we need to balance this equation because this is not following the conservation of mass. So steps of balancing chemical equation. Step 1. To balance a chemical equation, do not change the given chemical formula. I told you, right? You need not to alter the equation which is given to you. Keep it as it is. It was this. Okay. So you need to check it. Take it. LHS, RHS. So step 1 is to write down the number of element present here. Fe, H and O. Count the numbers. 1, 3, right? 1, 3. Fe, okay? I'm telling about Fe. H2, 2, 2, O, 1 and O, 4 over here. This is the normal table that you need to get as a step 1. You need to check the number of element. You need to check the number of atoms of element in present in left hand side and right hand side. This is the step 1. This is a very crucial step, because if you do this wrong, then you won't be able to balance it properly. Then this the number of atom of different elements present in the unbalanced equation. You got to know that F, E, H and O, how many number of atoms were present in LHS and RHS. So the list the number of the atoms of different element present in the unbalanced equation. You made a list, and then in a compound, it may be a reactant or a product. Select the element with the maximum number of the atoms and balance that equation. To equalize the number of atoms, it must be remembered that we cannot alter the formula of the compound or elements involved in the reaction. We need not to alter, okay? We cannot alter the formula of the compound or element involved in the reaction. So at first, you need to see that which compound has the maximum number. Okay, so here the number of Fe was 1, here is 3. So what will you do in order to balance the chemical equation here? You will multiply it by 3. So here 3 comes, here the 3 comes. Okay, so this is the approach. Okay, you will need to have it very clear. Once you will practice this, you will get it very smooth. Okay, so I trust you. I can make you trust on this. Like, if you follow this step, what was the first step? Make a table of left hand side and right hand side. Then you need to count the number of element present in the reaction. Then you need to, in second step, then you need to write down the number of atoms present in each element of left hand side and right hand side. So this is a very crucial step. In third step, take the maximum number of atom. Okay, take the maximum number of atom and balance that equation. So here you can see that the number of oxygen present in left hand side is 1, and here the oxygen present in the right hand, number of oxygen present in the right hand side is 4. So this is the maximum. Okay, so here what will you do? You will balance the oxygen. Okay, so this will get 4. So here what equation that I got? H2O gives Fe3O4 plus H2. Okay, let me write it over here. 3FeH2O Fe3O4 plus H2. We balanced the iron atom. Now we are balancing the O atom. So here you will write 4. Okay. So you must be thinking that the equation is balanced. But did you count the H atom? No, right? Here the H atom got 8 and here 2. So let us see what we will do in the next slides. Step for balancing the chemical equation here is, like in third step what was written, that you need to know, you need to see that what is the maximum number of atom, maximum number of atom of which element is present in the left hand side or right hand side. So you got to know that okay, so you got to know that I'm making this mistake again and again. I will not do it again. So O4, here is 1, here is 4. What will you do? You will do this. You will add 4 in order to balance the oxygen atom, number of oxygen atom. So what will happen? Here oxygen got balanced, but still this is a partially balanced equation. You need to do more in it in order to get a perfectly balanced chemical equation. Step for balancing the chemical equation. So step 4, to balance hydrogen on both the side, make the number of molecule of hydrogen as 4 on the right hand side. Right. So thus the equation thus becomes what? Because the number of hydrogen got exceeded in the left hand side. Okay. So you will do this. So the oxygen hydrogen is balanced. Now what got left? Iron. Check the number of the remaining element. This is the only thing left in the in this chemical equation. To balance the iron on both the side, multiply Fe with coefficient 3 on the left hand side. So the reactant and product. Initially the left hand side, okay. The left hand side was having only Fe, and it was this here. So here you will just in order to balance it, you will multiply it with 3. What will you get? This is the perfectly balanced equation. Okay. So the Fe, H and O got balanced. So what? To check the correctness of the balanced equation, we count atoms of each element on both the side of the equation. Okay. Fe is balanced here. You can see H2 is not balanced because here the 4 is not written. O is balanced. 4 and 4. Fe3O4. But here the H is not balanced. The number of atoms of element on both the side of the equation are equal. This equation is now balanced. Okay. But H is not balanced. So what will you do in order to balance this equation? What got left? 4. The number of hydrogen atoms should be 8 because there are 4 number of hydrogen molecule. So here also you will add 4 in order to have the 4 atoms of H in both the side. So Fe, H and O is balanced. So now you can see that this is the perfectly balanced chemical equation. Step 7. This was still not a perfectly balanced chemical equation because notations got left. So what are the notations? So when you write Fe, the iron is no doubt in it. Okay. H2O is liquid. What is this? H2 is gas. Fine. This is also solid. So in order to have a perfectly balanced chemical equation, you need to have the perfect notations out of everything. So this is 3, 4. The 4 got balanced. 3, 3. Here the 4 will get add on. This is the perfectly balanced chemical equation. This is following the conservation of mass. So in order to get a perfectly balanced chemical equation, what were the steps? First, make a table. Write down the number of atoms present in the left hand side and right hand side, and this you need to ensure that everything is written properly, because if you count the number of elements wrong in both the side, then you won't be able to get a perfectly balanced chemical equation. You will get confused. So this is it. Let's get into another thing. Step for balancing chemical equation. The final balanced chemical equation got this. Okay. With the proper notation, with the proper number of atoms in both left hand side and right hand side. Sometimes the condition required for the reaction, such as temperature, pressure, catalyst, etc., are written above or below the arrow in the equation. For example, catalyst. What do you mean by this term catalyst? It it decreases the activation energy of the reaction, and it helps the reaction to get into a proper direction, and it fastens the duration of the reaction. Okay, it helps the chemical change in it. So the temperature, pressure, and catalyst are the requirements of the chemical reaction to take place. Okay, so for example, you can see here that the carbon monoxide along with the H2 molecules under the 340 atmospheric pressure, this was methanol formed. Okay, so under this pressure the chemical reaction happened. So every requirement that is happening in the reaction you need to write down in above the arrow, like whatever be the temperature, whatever be the pressure, and whatever the catalyst you are using right in the equation, you need to get it in the top of the arrow, because this suggests that because of these requirements the chemical change is happening, and without this the chemical reaction will not occur. Okay, so let's get into the question number 1, and this question number 1 is very important from the exam point of view. You need to concentrate more on this, and I am telling you this question will be asked because this is important. This is a very basic question that you need to understand in this chapter. Why should a magnesium ribbon be cleaned before burning in air? Because you never start an answer with the because. Okay, write a full statement. Magnesium ribbon can be cleaned before burning in the air because magnesium reacts with oxygen to form magnesium oxide. In order to get it efficiently burned, you need to clean the magnesium ribbon before burning. Okay, this is the proper answer, and this is important because when magnesium ribbon is kept for a long time in the atmosphere, this gets reacted with the atmospheric oxygen present around it, and it forms a magnesium oxide layer in it. So in order to get it efficiently burned, you need to clean it before burning in the air. Okay, now let's get into the question number 2. These are the type of question that will be asked in the exam. So write the balanced equation for the following chemical reaction: hydrogen and chlorine, hydrogen chloride. Some of people will write it as this, and this, but you need to know that a single atom of H does not exist. It exists in a bivalent nature. Okay, this also exists in bivalent nature. So that is how the hydrogen chloride is formed. And do you think that this is the equation is balanced? I need to write 2 over here. That's how this is the equation balanced. Break it. NHs and RHs. What do you see over here? The number of atom of H is 2. The number of atom of the number of atoms of Cl in left hand side is 2. When the hydrogen chloride was formed, then you need to add the 2 in it. So you will get to see that the number of hydrogen and number of Cl is balanced. So this is it. Barium chloride. You need to learn this, that the barium has valency 2. It has 2 electrons in the outermost shell. So the formula of barium chloride will be this: aluminium sulfate. Am I writing this correct? No, because you need to learn this, that the formal charge of sulfate ion is -2. So this is this. And what is the valency of aluminium? 3. Yeah. So this is it. Barium chloride and aluminium sulfate reacts each other, and the product is barium sulfate. It got cancelled out, okay? The 2 valency of barium and the formal charge of sulfate, so you need not to write it. And aluminium chloride. So this is it. Sodium plus water. So is this equation balanced? See, check it out by yourself. What was the first step to balance the chemical equation? Make a table. Write down the elements. What are the elements? Barium. I am overwriting in it, so I will just make a new table. So what are the elements? You need, first step to balance any chemical equation is that you need to count the number of element. Barium, aluminium is present. Okay, S, O, and what got left? Fluorine. So here the number of atoms of barium is 1, 1. You need not to change it. Okay, aluminium 2, 1. You will have to change it. Sulfate. Okay, this sulfate is, though it is in bracket, you can get the 3 inside the bracket. So the number of sulfate ion here is 3. Okay, and the number of oxygen atom is 12. Right? Array, just multiply it. Okay. This is the simplest form that I can explain to you to open the bracket. Okay. Also, what is the number of fluorine? 2. Now, what about the RHS? Sulfur here is 1. Okay. Oxygen is 4. Chlorine 3. Now what will you do over here? Okay. Let me just explain you it very briefly, because this is important. So barium chloride plus aluminium sulfate. Barium sulfate plus aluminium chloride. Take the maximum number of atom in the equation. Oxygen is 12. What will you multiply over here to get it 12? 3. Add 3. Okay. When you add 3 here, and that moment check if the other atoms got disrupted, number of other atoms got disrupted or not. So you balanced oxygen, check sulfur and barium. So sulfur in left hand side was 3. It got 3 because we added 3. So the sulfur is balanced also. What do you see here is that barium got 3. Now you need to add 3 in left hand side. So this is 3. This got 3. Okay. So when you added 3 here, you need to check the other atom if it is balanced or not. So here the 2 atoms of fluorine was present. So what will happen next? Here the chlorine got 6 because 3 atoms of chlorine molecule. Okay, molecule, that means the chlorine exists in the bivalent nature. So this is the 3 atoms of chlorine molecule, but the number of atom of chlorine is 6. Multiply it. Okay, so it got 6. So what will you do in the right hand side? You will add 2. Okay, so when you add 2 over here, the number of the chlorine atom is balanced. 6 and 6. When you add 2 over here, you need to check if the number of atom of aluminium got disrupted or not. So aluminium was 2. So either or that way we had to add 2 here. But because in order to balance the chlorine atom, we added the 2 here. So this equation is properly balanced. Okay. Yeah, this is it. This is the complete balanced chemical equation. So to approach the equation, to balance any chemical equation that is in front of you with the uttermost confidence, first step, make a table. Count elements. Second step, elements count किए, table बना दी. You need to count the number of atoms of elements in each. These are the things that you need to do in your second step. Okay. Count the number of atoms. In third step, take the maximum number of atoms. I took oxygen because it was 12. So I balanced it in the where? Right hand side. Then at that moment when you balance any atom at first step, there and there you need to check if because of adding that number in front of the compound, did you disrupted the number of atoms of other element? Like I added 3 over here, so I abruptly checked the number of sulfur and barium. So this is how is the correct approach of balancing in chemical equation. So these three are very crucial steps. I consider the second step very crucial because if you do not count the number of atoms in right hand side and left hand side clearly, then you won't be able to get the whole equation properly balanced. So now let's get into the third. This sodium plus water, what does it give? Sodium hydroxide plus hydrogen. So is this balanced? Is this balanced? How do you check it? First step, table. बना दो. Left hand side, right hand side. NaHO. Number of Na 1 1. This is the scoreboard of any cricket game. Okay. You must not be able to see this. Okay, I will just write it here. Okay. LHS, RHS, NaHO. Scoreboard 1 1. H. Here is 3. In left hand side it was 1. No, it was 2. Because it got reacted with water. In right hand side it is 3. Oxygen in left hand side is 1. In right hand side is 1. So in order to balance the hydrogen gas, what will you do? You will do is that here approach this equation as here it is 3. Okay. So you need to do hit and trial method. Okay. Here just add 2 in order to balance it. When you add 2 over here, you will see that the number of hydrogen got 2 in NaOH, sodium hydroxide. So the total number of H atom in right hand side got 4 due to the addition of 2. Yeah, right. 4. So in order to make this 2 4, what will you do? This. So just add this. At that moment when you add 2 here, it got 2 H2O. Check if the other atom, number of atom got disrupted or not. Oh, but it got disrupted because in left hand side it got 2 and in right hand side it is just 1. No, it is not just 1 anymore, because when 2 was added in NaOH, it got automatically 2, so this equation is balanced. So this Na plus 2H2O gives 2 NaOH plus H2. This is the proper chemical equation of it. Write a balanced equation, chemical equation with state symbol for the following reaction. Okay. Solution of barium chloride and sodium sulfate in water. Barium chloride reacts with sodium sulfate. Okay. React to give insoluble barium sulfate plus, and the solution of what? Sodium chloride. Sodium is denoted as Na and it got sodium chloride. So this is in the form of aqueous, because this is and the solution of sodium chloride. Okay. And BaSO4, barium sulfate, is insoluble. It got precipitated. Precipitated means that whenever you add any um, reactant over here, and because of the because the product got formed, there is some formation of insoluble things like barium sulfate, and this is insoluble in the aqueous solution of NaCl, so it got precipitated out. It will settle down in the bottom of the test tube. Okay, so this is it. So this is in solid solution of and in water. So these all is aqueous. Okay, this is it. This is how you approach any question. At that moment, write down the answer of the compound written over here. Then next, sodium hydroxide in water, this is the aqueous, reacts with hydrochloric acid. This is also in water, so it is aqueous. Produce sodium chloride in water. This is in the form of solid and this is from liquid. This is in the form of liquid. So this is the proper annotations of it with proper balanced chemical equation. Did you notice here that this is not a balanced chemical equation? Here the number of Na is 2 and here the number of Na is 1. So what will you do? Add 2 over here. You know, to follow the to maintain the number of atoms in both these sides, you then and there need to check whether the equation is balanced or not. Once you have the practice, you will do this mentally. So you need not to make the table first, then write down the atoms. Okay. As soon as you do not get it right in your mind, in your table form, just try to practice it more and more. Okay, so then and there when you add this 2 in front of NaCl, then you need to see that whether the number of atom along with it got disrupted or not. So here it was only 1, but when you added 2, it got balanced. So this equation is balanced now because the number of Ba is same, the number of Na is same, the number of sulfur is same, the number of O is same. Okay, so this equation is wholly balanced. And here you see that 2H is present. So in LHS 2 hydrogen is present, 2 hydrogen is present. This equation is balanced. Then 1 Cl, okay. Then 1 sodium and 1 sodium. So this is a properly balanced chemical equation with the proper annotations representing the equation. Okay.